So we're going to look at a method of generating volumes by using what we call shells, okay, or cylindrical shells. So basically what we're going to do is we're going to generate these cylinders of shells, okay, and we're going to calculate the volume of each one of these shells and add them all up. So to generate these shells, we're going to start with this rectangular area here. Okay, so this rectangle has a height of f of x. It's going to have a width of dx. And what we're going to do is we're going to spin that rectangle around, okay, around the y-axis in this case, and we're going to generate these different shells. So all those different rectangles will generate these shells. Okay, and we're going to get all these concentric shells of which we can calculate the area for, or sorry, the volume for each one of these shells. So we're going to generate this shell. To calculate the volume of this, we're just going to unwrap it. So it's going to end up being a rectangle. We're going to flatten it out. We're going to end up with a rectangle that looks like this. Okay, we're going to have the rotation around the axis is going to generate a circle. Okay, the radius of that circle is going to be the x position wherever we get that rectangle. So that becomes a radius. So we get 2 pi times x, which gives us the circumference, which gives us that length along here. The height of that rectangle is going to be f of x, and then we give that rectangle some thickness, dx. Okay, so we're going to give it some thickness of dx. Okay, so that thickness will be represented by dx, and each one of these we can calculate volumes for, and then we can sum up those volumes to get the volume of that whole shape. Okay, so I'm going to show you some animations of how this looks like and how these pieces generate these shells.